to a screencast that's going to address the setup of the lab for cell respiration. So what we're trying to do here today is, first of all, you want to look at the PreLab worksheet that's posted on Blackboard and course documents. This goes along with that. So we're going to try to talk about briefly the purpose, but really focusing on materials and the methods here so that we can come into class and get ready to get that set up and get ready to go. So ultimately then, by understanding the materials and the methods, you will be able to explain how the rate of respiration can be measured. Right? This is quantified. Right? And then what, along the way, explaining the purposes of the KOH, which is potassium hydroxide. You're going to see some glass beads, so why do we need glass beads in there? And then this little bit about corrected differences, and this has to do when we talk about this data analysis. Right? So data analysis coming down here to the corrected differences part. So let's get right into this. I showed you in class what the materials are basically going to look like. We're going to have a green tray right here, which we've seen before, and we're going to put water in that green tray. Here is our organism, and these are going to be pea seeds. And we're going to have some that are germinating, some that are non-germinating. So we're going to have germinating pea seeds and non-germinating pea seeds. Here are the glass beads. This is the potassium hydroxide. Here is the chamber. It's circling in black. It's not really that good. So this is the chamber. And then here is the graduated pipette. And then here's a graduated cylinder that you're going to use, and this is a glass stirring rod. And then here we've got absorbent cotton and non-absorbent cotton. So these are all the materials we're going to use. Oh, and a thermometer. I didn't throw a thermometer on there, but we want to know what the temperature is of that water bath there. So first things first, here's what's going to happen. Step number one, you're going to take your chamber here, and you're going to put some absorbent cotton in the bottom. And this is about 1 finger width of absorbent cotton. It's highly quantitative there. So 1 finger worth of absorbent cotton, stuff it into the bottom of that chamber there. Then you're going to, step number 2, is you're going to saturate the absorbent cotton with KOH. Right? So here I am dropping the KOH in there. You want to be careful to not get it on the side. Do not get it on the side of the chamber. Make sure it drips straight down into there. And you're going to saturate that. So this is anywhere from a dropper full of this to a dropper full and a half to get that cotton saturated down in there. Right? Step number 3. So 1, 2. Step number 3 is down here. You're going to use this glass stirring rod to tamp down the absorbent cotton in the bottom there. And then step number 4 is you're going to put some non-absorbent cotton on the top. Right? Non-absorbent cotton goes right on top there. Right? And you can kind of tamp that down a little bit as well if it's sticking way up. So you want to have plenty of room here in the chamber, right, to put your organisms. Right? So that's the first setup. You're going to do this this times 3. Right? 3 times this. You need 3 of these respirometer chambers set up. So as soon as you get in, get your respirometer chambers, start getting them set up thusly. Then you're going to use the graduated cylinders here, and you need to know the volume of your germinated seeds and your non-germinated seeds. I don't have a picture of germinated seeds at the moment, but you're going to use the germinated seeds first, right? So you're going to take germinated seeds here, and I'm thinking that we're going to use around 10 germinated seeds. So you're going to put those germinated seeds into this graduated cylinder that has, and I filled this up to about 50 mLs right there. So we're going to use a volume displacement method to figure out the volume of those germinated seeds. Right? Then you're going to take those seeds out, right, dump the water out, dump the germinated seeds out gently, and that volume, right, So the volume of the germinated seeds you need to know. Right? Then, after that, you're going to take your non-germinated seeds, right, and the same number, right, so this is going to be around 10 of your non-germinated seeds. Right? You're going to put those into another graduated cylinder, right, and you want to then, so that volume of these non-germinated seeds is going to be less than the volume of these germinated seeds, simply because these germinated seeds are going to be larger, right? So you need to make up the difference of that volume with these glass beads, right? So what you're going to do is on the right here, I've put these non-germinated seeds into the graduated cylinder, and then I put glass beads, enough glass beads in here to make that volume here. So I started here, and to make this volume of the non-germinated, right, equal the volume of the non-germinated is equal to the volume of the germinated. Right? If you didn't follow that, go back and rewind that and do that again. Right? So you are going to do this volume displacement method for the 10 germinated seeds first, and then find the volume of the non-germinated seeds, which is going to be less than the volume of the germinated seeds. You're going to make up that difference in volume with these glass beads added to the graduated cylinder. Then you're going to quickly then take the glass beads and those non-germinated seeds, right, or the germinated seeds as the case may be, put them on a paper towel, right, pour the water out, right, in the sink, right, and then pour these onto a paper towel, right, and then blot them dry, right, a little bit. Then you're going to transfer these into your respiration chamber, right, or respirometer chamber. So after these are blotted dry, they get added here, and then you put the top on thusly. Right? You want to make sure that this is a tight seal here, and make sure that there's a tight seal here where the pipette, this is a pipette, tip meets the stopper. Right? And if this is loose at all, you need to let me know so that we can make that tight again. Right? So you want to have tight here, and you want to be tight there, so that any gas that you are trapping stays inside that respirometer. Right? Now, this is a one-hole stopper. This pipette is jammed in there, so again, make sure that that is sealed up tightly. Next step is these water baths will already have been filled probably with water, and this water will be at room temperature. You're going to take your assembled respirometers and you're going to lay them down in the water so that the tip is out, it's resting on the edge right here, and so this is where this kind of comes out of the water. So this is all submerged, right? And then this is out, not submerged. Right? If this is having a hard time, if this is kind of floating up and not staying submerged, I'll show you. You can just put a test tube rack across that, and I'll show you that in the next image here. But you want to submerge this. I believe the protocol, the procedure, says for around 10 minutes, right? I think, or maybe it's less than. I gotta check. But you want the temperature inside here, inside the respirometer, to be the same as the temperature in the water outside. So you got to let that come to temperature there. So here's what I was saying about the test tube rack. Right? This is the top view, and then here's a side view. Right? So just put the whole test tube rack down into the water bath, right? So that it holds the respirometer, underneath the water. Right? So after that 10-minute incubation time, now you're going to move that and adjust it so this is also submerged. Right? So the whole thing is submerged underwater. Right? Now, what's going to happen is in this pipette, when it was sitting out there, this pipette was full of gas, right? It was full of air. But as you submerge this, right, what's going to happen is that the atmospheric pressure pushing down on the water here is going to push some of that water into the pipette. Right? So you're going to have water here, and there's going to be an interface. There's going to be a meniscus right here, and on this side is going to be air, and in that air is gas, and the gases in there is O2, right? Primarily, right? Because the atmosphere is around 20% oxygen, right? And then less than 1% CO2. So that's primarily oxygen gas in that pipette right there, and oxygen gas inside the respirometer chamber there. So this is the setup. Now, when that water moves into the tip of the pipette, so the tip of the pipette is here, and the chamber is going to be on this end, right? You see that right here is the meniscus, right? Right there is the meniscus, right? And so you want to read the volume using this graduated pipette tip. Notice that this line right here is 0.7, and this line right here is 0.6, and this line right here is 0.5. Right? So what is the volume if the meniscus is right here? Right? What is that volume? Of oxygen. So where is this, right? So this side is air, primarily O2, and this side is water here. So this volume is between 0.6 and 0.5. So this is going to be 0.51, 0.52, 0.53, 0.54, 0.55, 0.56. So you would read this as 0.56 milliliters. So you have to adjust, when you submerge your respirometer in the water, you have to adjust the respirometer, twist it, turn it, so that you can see the numbers here, the values, right, as well as the increments, right? So the values, the numbers, as well as the increments here, and make sure that you can see the bubble, right? Make sure you can see the meniscus. Right? If that meniscus, you see it, and then you all of a sudden it starts to move real quick, that means that you might have not a tight seal here, you might not have a tight seal right here, and you might see bubbles of gas, oxygen coming out of there. If that's the case, you got to stop, you got to take this out, you got to restart the whole thing. So you got to get a new stopper, a new pipette tip, etc., right? And then resubmerge that, okay? There's occasion where the meniscus is sort of only right here at the tip, right? So here's the tip, right? And the meniscus would be right there, where this is going to be water and this is going to be then O2. Can I read that volume? The answer is no. So if that's the case, then what you got to do is you're going to have to put another pipette sort of right next to this one, right? And then line it up so that then I can see where that is. So the meniscus would be right there. So this would be 0.91, 0.92, 0.93. Right? So I'd read that as 0.93 as my starting spot. Right? So if that's the case, then that's what you're going to have to do. But you need to get this initial volume, right, in there. So the initial volumes are going to get recorded here at different time intervals. Now, these time intervals, we may go every 3 minutes, right? So 3, 6, 9, or we may go 2. We'll see how quickly you're able to read that. But the initial volumes are going to go here, right, in this initial volume, right? So initially, where was it at? We had it at 0.5. Well, I think I said it was 0.56, right? So then this initial volume is the same all the way down. So this is going to be 0.56 all the way down. Then the final is after 3 minutes, where is it? And then after 6 minutes, where is it? So the volume is going to be changing, or should be changing. Maybe, maybe not. I don't know. Well, you're going to sort of think about that, right? So the final, and then what is that difference? The difference here is how much oxygen gas was used in that time frame, right? So this difference here is final minus initial. So if you come up to the top here, right, the initial is the meniscus reading at time 0. Fill this value in down each column. Number 2, the final is the meniscus reading at time x, and where this is time x. the difference is the initial, right, reading here minus the final. And then this corrected difference. Now you notice that here in the control thing here, you don't have any seeds. This is just beads. Right? The corrected difference doesn't come into play until over here and over here. So this lab setup lets us talk about having a control group as well. So you're going to need to, in the lab, get all these initials and all these finals. Then at home, you can do the difference calculations, and then you can do the corrected difference calculations. And again, here is what the corrected difference is. Okay? Following this, we are going to do some data analysis. We're going to use this to talk about standard deviation, standard error, and we're going to then calculate a z-score, right, for your individual group. Okay? So that is materials and methods for the lab. Again, what you should do right now is go back and think about the purpose, right? What was the purpose of this lab? Number 2, can you make some predictions? And then 3, how are we going to measure, right, or calculate rate of respiration? One thing I did not mention that I just realized right now is to go back and just talk real quickly about that KOH. Right? If I go all the way back here, that KOH that you're putting in, right, initially here, you can read in the pre-lab here about that KOH and what is the purpose of that KOH. Why are we doing that? Okay. Hint, has something to do with carbon dioxide, right, oxygen, ideal gas law. If you don't remember the ideal gas law, go and Google that or look it up in your chemistry textbook. Okay? Thanks. Bring your questions and clarifications to class.